All right, what up, everybody? Let's go ahead and begin with our very last section of this Unit 10. This is it. This is the last bit of information that we are going to be covering in this class of statistics. And again, we are looking for differences, differences that may exist between two different things. And again, we're going to do this in two different ways. One way that we're going to find a margin of error in a confidence interval. That's how we're going to handle number one. And then we're going to be making a hypothesis test with the curve and the p-value and everything of the second version. That's how we're going to handle number two. All right. So we begin with the confidence interval kind. All right, so things that you need to know. All right, so one thing that you need to know is you need to know p hat. P hat is, again, r divided by n. It's the small number divided by the big number. Okay, that's what a p hat is. You also need to know a q hat. Q hat is 1 minus p hat. All right, you need to know that. And obviously, you need to know how to find a ZC. Here we have a confidence of 95%. So again, you just straight up look up that on the Z table. Let's go ahead and actually take care of that right now. So confidence of 95%, a ZC. So again, you look at that Z table, that little box. This one we are looking for 95%. So our ZC is 1.96. Okay, several different questions that we need to fulfill. What I do first and foremost is I get these answers inside the box for my p hats and q hats for both 1 and 2. All right, so p hats and q hats for 1, r is 13, n is 47, so r divided by n in that situation is 2766. So 1 minus that is your q, which is 7234. All right, going to the p hat, q hat of 2, the r is 39 and the n is 84. So the p hat of that one is 4643. And the q hat, again, 1 minus p hat, is going to be 5357. Okay, off and running. Okay, so we are going to be making a confidence interval in this situation. The first question, question A, is asking for the margin of error. So here comes a formula. The margin of error in this situation is p hat 1, q hat 1 divided by n1 plus p hat 2, q hat 2 divided by n2, and that bit is square rooted. All right, so it looks a lot more rough than what it is. You pretty much type this in just straight away. Okay, so I go p hat 1 times q hat 1 divided by n1 plus p hat 2 times q hat 2 divided by n2. Okay, that will get you all that inside bit. All right, so from there you would square root that answer. Okay, and then from that you multiply by ZC, which in this case is 1.96. But again, it looks a lot worse than what it actually is. It's really not that bad. So here we go. Let's start with that inside bit. And so that's p hat 1 times q hat 1 divided by n1 plus p hat 2 times q hat 2 divided by n2. Okay, not so bad. That gets us that inside piece. We need to square root that. and need to multiply by ZC. So that's equal to 1665. All right, easy peasy. Next is the confidence interval. So the confidence interval in this situation is p hat 1 minus p hat 2 minus e is less than p1 minus p2 is less than p hat 1 minus p hat 2 plus e. So this middle part stays the same. And I get the two answers to the two sides. So this is p hat 1 minus p hat 2 minus e and then p hat 1 minus p hat 2 plus e. All right, so what I see in this situation is that they're both negative. So p hat 1, excuse me, the regular p1 on the middle part, p1 minus p2 is less than 0. They're both negative. So that means p1 is less than p2. So again, B stands for probabilities. And again, look at the R for the meaning behind what these probabilities. So these are probabilities of an error. So the probability of an error from 1 is less than the probability of an error from 2. Writer A. So the probability of an error from writer A is less than the probability of an error from writer B. Since I already described the error, I don't have to mention it twice, but you do have to say the probability of 1 is less than the probability of 2. So again, make sure you double use that word probability and just fill in the blanks. It's very, very, very similar to the averages of that we did in assignments C and D. Okay, here we are looking for a hypothesis test. So one thing that we don't need in this situation is we don't need these Q hats. All right, so we're kind of off the hook as far as that goes. All right, so again, things that you do need to know. You need to know a P hat. P hat, again, is R divided by N. Okay, a new thing that we're going to be getting is a P bar, which is kind of like the average, if you will. And so what that is going to be is R1 plus R2 divided by N1 plus N2. Again, make sure those you have a distinct numerator and denominator. So use the fraction button in your calculator, or again, make sure you use parentheses. Okay, here you also need a Q bar, which is 1 minus P bar. All right, that will get you going, and then I will let you know about these other variables when we get there. Okay, so let's find these P hats. P hats are R divided by N, so R divided by N. R divided by N. Okay. First question is asking for find P bar and Q bar. So P bar again is R1 plus R2 divided by N1 plus N2. So that's 123 plus 108. Again, I have to use parentheses. I don't have that cool fraction button. And then N1 plus N2. Okay, Q bar in this situation is 1 minus P bar. And that's how that's done. Okay, a few different things going to go on here. First is the z-score, and that z-score is going to lead you into the p-value. The z-score in this situation is kind of a big one. So it's p bar q bar divided by n1 plus p bar q bar divided by n2. That's square rooted as the denominator of p hat minus p. Is it the p hat 1 minus p hat 2? I'm sorry. Okay. How I begin this one is I begin with the fractions on the inside of the denominator. So how I begin this is I go p bar times q bar divided by n1 plus p bar times q bar divided by n2. So that will give me the fraction of that denominator. So let's go ahead and start there. So I go p bar times q bar divided by n1, 750, plus p bar times q bar divided by n2. All right. So that is the fraction, that's the big messy part of the denominator. Okay. To get the complete denominator, I have to square root that answer. All right, so that is the complete denominator. Now I need to take this numerator divided by the denominator. However, division doesn't work well with subtraction, so I need to make sure I have my p hat 1 minus p hat 2 in their own unique parentheses, and then I can go ahead and divide by the denominator that I just established. Okay, this is a z, and so this is negative 2.32. All right, next comes the p-value of this. Right here. So the p-value of this is going to be built upon a z of negative 2.32. Remember, you would always look it up as a negative no matter what. So negative 2.32 from the z table. So negative 2.32 is 0.102. All right, that's the p-value of this situation. So what does that mean? I see from the problem that this is a left tail. This is a left tail with an alpha of 5%. again, look at the problem and you can figure all that out. So alpha is 5%. I have a value of 0.01, so my p-value is way smaller. Okay, so what I just found is that the p-value is less than my alpha. That means I reject H0 and accept H1. So H1 in this situation says P1 is less than P2. So that was very nice. Told me exactly what I told. So P1 is less than P2. That's what accept H1 would say. So P1, the probability of 1, which is, look for the R, a claim. The probability of a claim of group A is less than the probability of a claim from group B. And again, if it's do not reject H0, just like how we did in the averages, we are unable to prove a difference between the probabilities of 1 and 2. So we are unable to prove we're unable to prove a difference in the probabilities of the claims of group A versus group B. Again, make sure you use the word probability in there. All right, here we go. So we got, again, another confidence interval and then a hypothesis test down here. So again, a p hat is r divided by n, a q hat is 1 minus p hat, and then we need a ZC in this situation, and that is coming from a confidence of 90%. So I think that was 1.645, same one used up front. Yeah, well, 1.645. Excuse me, I'm sorry. 90%, yes, 1.645. I just remember it from other problems. All right, 1.645 is a confidence of 90%. Okay. So let's go ahead and find our p hats and q hats. The first one is r divided by n. One minus that. Most of this is just following along the formula. Just follow the formula. So the first question is asking for the margin of error, which is CC. Again, this is going to be p hat 1, q hat 1 divided by n1 plus p hat 2, q hat 2 divided by n2 square rooted. Okay, so again, just follow the formula. Follow the formula. So p hat 1 times q hat 1 divided by n1 plus p hat 2 times q hat 2 divided by n2. and you square root that. There you go. So that's the square root times ZC. Okay, so we have our margin of error. Again, just follow the formula. Next, we have our confidence interval. Our confidence interval in this situation is p hat 1 minus p hat 2 minus e is less than regular p1 minus regular p2 is less than p hat 1 minus p hat 2 plus p. So that'll be, move the decimal 3 places, so that produces 2 zeros and a 2-7, but long story short, it's a positive number. We'll kind of smashing it in here. Anyways, those are two positive numbers. So what that is saying is P1 minus P2 is a positive number. That means it's greater than 0. That means P1 is greater than P2. So the probability of 1 that's meeting their target growth, probability of 1 is greater than the probability of 2. I'll just say 1, which is Kendra. So the probability of Kendra meeting her target growth is greater than the probability of Lisa meeting her target growth. Okay, so again, in these problems, you do not need the Q's, you only need P hats. So let's go over these formulas one more time. P hat is R divided by N. Down here, we're going to have to get a P bar, which is R1 plus R2 divided by N1 plus N2. And we also need a Q bar, which is 1 minus P bar. Okay, so let's go with these hats. 146 over 257. 200 out of 380. Okay, P bar is R1 plus R2 divided by N1 plus N2. One minus that is going to get you your Q bar. Okay, now here comes all the other stuff. All right, so Z in the situation is P bar, Q bar divided by N1 plus P bar, Q bar divided by N2, square rooted as the denominator of P hat 1 minus P hat 2. So we'll work with that denominator. So that's P bar times Q bar divided by N1 plus P bar times Q bar divided by N2. All right, square root that. And then I make sure I put the top in its own unique parentheses divided by the bottom. So it's 5, 6, 8, 1 minus 5, 2, 6, 3 divided by the bottom. All right, so that means the p-value in this situation is built upon a z of 1.04. So look at the z table, negative 1.04, you always look it up as a negative. Negative 1.04, 1492. All right, so looking at the problem, this is indicating that this is a right tail with an alpha of 5%. $14.92 is pretty big. So see that the p-value is greater than our alpha. That means do not reject H naught. That means our answer is going to be the H naught. So let's see what that says. H naught says P1 is equal to P2. Okay. So we're unable to prove a difference between. We're talking about your probability. R owns more than one dog. The probability of multiple dog ownership of 1 versus 2, 2000 versus 2010. Make sure you have the word probability somewhere in that answer. So we are unable to prove a difference between the probability 2000 versus 2010. That's kind of like the long story short when you have this or equal to, is equal to kind of answer. So that's it.